Okay, so I went through all of the bits we did to get to these last two parts of this question. So we found out the area of the triangle OCP to be 2 root 5. And the last question we did was to find the two sectors. So area of sector OPQ, we used this as the angle and a radius of 3 to get 6.57, and then area of POQ. So we used an angle of 48.19, the radius of 4 to get 6.73. So the next question, the next question that we're being asked is to find the area of this shaded region here. So the way I did it was to find the area of the semicircle OPS, so it's a small semicircle, minus the sector OCP, which is this sector over here, which we already know, and then minus this little sector here. Okay, so if you have the whole thing, minus OCP, minus CQP, you'd be left with the shaded region. Okay, so to get the entire semicircle, it's fine, pi r squared, and then half it because it's a semicircle. And we know the radius, it's a small one, so the radius is 3. The area of sector OCP, it's here, we've done already. Now, the problem is CQP, which is this little bit here. So the way I did it was the sector of OPQ, right, which we have already, it's here. So the sector OPQ minus the triangle OCP, and you'd be left with this CQP part. So that's what I have here, area of sector POQ minus area of triangle OCP. So the semicircle is a half pi 3 squared, which gives us this. The sector OCP we already had done, so 6.57. The area of sector POQ and the triangle we had done, so subtract them and you get the 2.26. So you do the semicircle minus the sector minus the little bit in the corner, and you end up with 5.3 units squared for the shaded region. Second part, or the last part actually, is find the perimeter of the shaded region correct to 1 decimal place. So the perimeter would be this arc here, PQ, this arc here, PS, and then QS along the bottom. Okay, so that's what I have, length of arc PQ, length of arc PS, and QS. So length of arc PQ, that arc is part of this sector, POQ, where the radius is 4 and the angle is 48.19. So the arc length is the 48.19 divided by 360 multiplied by 2 pi r, where r is 4. Same thing here, length of arc PS. Now I don't think we did this one, so PS is here obviously, so the sector you're talking about is like kind of this one here. Yeah, so the radius for that is 3, and then to get the angle, this angle here, you just do 180 minus 83.62. So that's where that came from. 180 minus 83.62 is 96.38, and then your radius is 3. So same formula, angle over 360, 2 pi radius, and you get 5.05. QS then, the bit across the bottom. So if O to Q, which is part of the big semicircle, is 4, and O to C is 3, then C to Q here has to be 1, 4 minus 3. But C to S is 3 because that's the radius of the small semicircle. So if you do that 3 minus the 1 that we got here, you end up with QS being 2. So that's sort of explained there, and I get that QS is 2. So you add the 3.36, the 5.05, and the 2, and you get, well, I would have added them not to 2 decimal places, I would have kept the full numbers in my calculator, but to 1 decimal place anyway, when you add them all up, the perimeter is 10.4.